Okay, Mr. Trutna, here we go. This is we're actually on unit 12. That's a typo, my mistake. I made that mistake on every worksheet for unit 12. This is section 2B. We're going to go over volume of pyramids and cones. Okay, so we're going to start off with pyramids for numbers 1 through 6, and then after we get with numbers 1 through 6, then we're going to go through cones. Okay, I'm not going to do every single problem. I'm just going to do some of the problems so you get the idea of how to figure it out. So for a pyramid, the formula is volume is equal to 1/3 times capital B times lowercase h. So remember, capital B stands for area of the base. That's what capital B is. So you're finding the area of the base. And then H stands for the height of the pyramid. Alrighty, so in number 1, you can see right here that my base is, I want to find the volume of each pyramid. So this is my base of my pyramid. My pyramid right here, that is going to be the base. And then the height of the pyramid is, remember the height always goes from the very top of the pyramid, which would be the top point there, and then the height goes down through the inside of the pyramid, and the height always goes to the middle, the exact center of whatever the base of the pyramid is here. So if I were to find the volume of number 1, I am going to take the area of the base, which we denote by capital B. I'm going to multiply it by the height of the pyramid, and then I'm going to divide by 3. Notice the formula over here. It says 1/3 times the area of the base times the height, but I just divide by 3. Multiplying by 1/3 is the same thing as dividing by 3. Okay, so the first thing we have to do is we have to find the area of the base. All right, so if you look over here, the base, you say to yourself, okay, what type of shape is the base? Well, the base is a rectangle. This is what the base looks like right here. So the rectangle, which is the base, the length is 11, and the width is 9. Okay, so to find the volume, I first have to find the area of this rectangle. So to find the area of the rectangle, we're going to go 11 times 9. Then we're going to multiply it by the height of the pyramid. The height of the pyramid is 16, and then we're going to divide all of that by 3. Alrighty, so that means that my volume is going to be, and having a calculator is definitely going to help. I'm going to multiply 11 times 9. Then I'm going to multiply that by 16. I'm going to see what that equals, which is 1,584. You can't really see it. The glare is taking this off. If I take that away, it might be a little bit easier to see. Still not. Okay, if I move it over here, you can see it. And then we're going to divide by 3. Okay, so my volume of this pyramid is 528. So that's my numerical volume. Then I put the measurements or the units, which is inches, and then we cube it. So the volume of number 1 is 528 inches cubed, or cubic inches. Okay, number 2, so I'm going to find the volume. So the volume is, I find the area of the base, noted by capital B. I multiply that by the height of the pyramid, and then I divide by 3. Okay, so you can see in this problem, the base is this rectangle right here. Okay, so what type of shape is, or since it's a rectangle, how do you find the area of the base, which is the rectangle? Well, you're going to multiply the length, which is 21, times the width, which is 6. So to find capital B, the area of the base, I'm going to go 21 times 6. Then I'm going to multiply it by the height of the pyramid. And the height of the pyramid is this line segment right here. Remember, the height of the pyramid always goes from the very top of the pyramid down through the inside of the pyramid to the dead center of the base. So the height is going to be 5. So I'm going to go 21 times 6. Multiply that by 5, and then I'm going to divide that by 3. And that's going to give me my volume. So multiplying that out on the calculator, I'm going to take 21, I'm going to multiply it by 6, then I'm going to multiply that by 5. I see what that equals, so that's 630. I divide that by 3, so my volume is 212. I put the measurements next to it, which is yards, and then I cube it. So my volume of number 2 is 210 cubic yards. Okay, moving on to number 3, same idea. So in number 3, we're going to find the volume of this pyramid. So once again, the formula for volume of all pyramids is you take the area of the base, you multiply it by the height of the pyramid, and then you divide that by 3. Okay, so here's my base right here. So you can see that my base is, actually in this case, it's a square. So there's my base. So how do you find the area of a square? Well, you multiply side times side, or length times width. So that'd be 30 times 30. So to find the area of my base, I'm going to go 30 times 30, and then I'm going to multiply it by the height. Okay, now, in this particular problem, you will notice that that line right there is 25. Well, that is not the height. That line is what is known as the slant height. Remember, the slant height goes from the highest point, the top of the pyramid, down the side of one of the sides. We call those the faces of the pyramid. So that's the slant height. So what we have to do in this problem is we have to draw in a height. Okay, so that line that I just drew right there, which goes right to the dead center of the base, that line is the height. So there's my height right there. So how do I find that? So remember, if you're given a slant height, to find the height, you're going to draw on the height, then you're going to connect the bottom of the height to the bottom of the slant height, and inside the pyramid you just made a right triangle. Okay, so what I'm going to do is I'm going to take this right triangle right here, and I'm just going to redraw it over here so you can see what the right triangle inside the pyramid looks like. Alright, so that right there is the height. That line is this line segment right here, which is 25. And then the bottom right here is that, which is half of 15. Remember, that's right in the dead center, so that means that's half. So this is going to be 15. Why 15? Well, it's half of 30. Okay, so how do I find the height? All right, so, and that's going to be my height of my pyramid. Well, I have to use Pythagorean Theorem. So I'm going to go h squared plus 15 squared. So one of the legs, h squared, plus the other leg, 15 squared, is going to be equal to the hypotenuse, which is 25 squared. Okay, guys, almost always, not all the time, but the vast majority of problems when you're doing these, if you're given a slant height in a pyramid, you're almost always going to have to use Pythagorean Theorem to find the height. Okay, so now I work this out. So I simplify it. So h squared I cannot simplify. 15 squared simplifies to 225. 25 squared simplifies to 625. I subtract 225 from each side of the equation, and that gives me h squared is equal to 400. And then if I know that h squared is equal to 400, to find h, what I do to 400 mathematically is I take the square root of 400. And the square root of 400 is 20. So that means my height of my pyramid is 20. So in my formula, my height is 20. So I'm going to go 30 times 30. That's going to give me the area of the base. I'm going to multiply that by 20. Then I'm going to divide by 3. So that means in number 3, working that out, my volume becomes 30. Can't see that. Let me move it over here like this. 30 times 30. Okay, then I'm going to multiply that by 20. I'm going to see what that all equals. 18,000, but then I have to divide it by 3. So there's my volume, 6,000. So in number 3, 6,000 is my numerical volume. Then I put the units, which is feet cubed. 6,000 cubic feet for number 3. Okay, let's do one more. Let's go ahead and do number 5. Well, let's do number 4. What the heck, might as well. We're living large right now in this case. So in number 4, you could see, so I'm going to find the volume. The formula for all pyramids to find volume is area of the base, denoted by capital B, times the height, denoted by lowercase h, divided by 3. Okay, so let's look at the base. So if you notice, the base is a triangle in this case, and so the base is that triangle right there, which I just outlined. All right, well, how do you find the area of a triangle? Now, this one's a little bit hard to see, but remember, to find the area of a triangle, you take the base of the triangle, which is 12, you multiply it by the height of the triangle, and the height of the triangle is that dotted line right there, all right, which is 7. So I'm going to go 12 times 7, and then you divide by 2. So it's base times height divided by 2. That's going to give me my area of my base, Then I'm going to multiply it by the height of my pyramid, and this line right here is the height of my pyramid. How do I know that? Because it goes from the top of the pyramid down through the inside of the pyramid to the center of the base and has to make a 90-degree angle. So my height of my pyramid is 10. Okay, and then I'm going to divide all of that by 3. So working this out to find the volume of this pyramid in number 4, I'm probably going to need a calculator, and here we go on the calculator. So I'm going to go 12 times 7. Okay, that's 84. Then I'm going to divide that by 2. That's 42. So all of that right there, 12 times 7 divided by 2 is equal to 42. Then I'm going to multiply that by 10. That's going to be 420. And then I'm going to divide by 3. So my volume is 140. So that's my numerical answer. Then I put my units in millimeters cubed. So number 4, the volume is 140 cubic millimeters. Okay. Number 5, finding the volume of this pyramid right here. And this pyramid's going to have a base that's going to be a triangle. So this one's going to be a little bit similar to number 4. Okay. So the formula for volume for any pyramid is area of the base, denoted by capital B, times the height, denoted by lowercase h, and then we're going to divide by 3. Okay, but now let's talk about the base. Okay, so I have to find the area of the base of this pyramid. Well, if you notice, and I'm going to draw what the base looks like, it's this triangle right here, where we have this line, which is 5. Then we have this line segment right here, which I don't know what it is, but we have that 90-degree angle. And then we have the hypotenuse right here, which is denoted by 13. Okay, so I have to find the area of this triangle. That's going to be my area, my base, my capital B. So how do I find the area of a right triangle? Well, remember, the formula for area of any triangle is base times height divided by 2. Okay, well, that number right there, that's your base of this triangle. So you're going to go 5 times, and then the height is this side right here. So the problem is I don't know what's the height of my base to find the area. Okay, so I have to use Pythagorean Theorem, all right, to find h. So I'm going to go one of the legs squared, which is h squared, plus the other leg squared, which is 5 squared, and that's going to be equal to the hypotenuse, and the hypotenuse would be 13 squared. Okay, remember the hypotenuse of a right triangle, which would be this side, is always the side that's across from the 90-degree angle. Okay, I'm going to simplify this out to solve. h squared stays h squared, 5 squared simplifies to 25, 13 squared simplifies to 169. Okay, now I subtract 25 from each side of the problem to isolate the h. That would now give me h squared is equal to 144. 169 minus 25 is 144. And now to find h, I take the square root of 144, which is 12. All right, so that means I'm going to go to find the area of my base. I'm going to go 5 times 12 divided by 2. So it's going to be 5 times 12 divided by 2. Then I'm going to multiply that by the height of the pyramid. And this right here is the height of the pyramid. Remember, the height of the pyramid always goes from the top of the pyramid down to the middle of the base of the pyramid. Has to make it 90 degrees, so that would be 19. And then I'm going to divide that entire result by 3. Okay, so working this out, then we got to work this out. So I'm going to work out all of that first. 5 times 12 divided by 2. So 5 times 12 is 60 divided by 2. That's 30. Okay, so all of that becomes 30. Then I'm going to multiply that by 19. That gives me 570, and you can't see anything that I'm doing here. There we go. You can see I went to 5 times 12, I got 60. I divided by 2, I got 30, multiplied by 19. Now I'm going to divide that all by 3. So 190. So in number 5, my volume is 190. Put the measurements, which is meters cubed. 190 cubic meters for number 5. Okay, I'm going to skip number 6. I expect you to skip number 6 as well. If you want to work it out, I could tell you if you got it right or not, but you're not responsible for it. Okay, so turning this over to the back side, now we're going to find the volume of cones in numbers 7, 8, and 9. So the formula for volume of cones is this. To find the volume, whoa, lights just went out. Holy cow. Sorry, I just wanted to see if you guys got scared staring at a black screen. There we go. We're back on. Okay, so what's the formula to find volume of a cone? Well, here's the one that I taught you. And it's the same one that's on the notes here. I just wrote it a little bit differently. You're going to take the number pi, you're going to multiply it by the radius squared, and then you're going to multiply that by the height of the cone, and then you're going to divide all of that by 3. And remember, we're going to use pi as equal to 3.14. So, and we know that's not what pi is equal to. We know that pi is a number that goes on, it goes on forever. So when we get an answer, if we use 3.14 for pi, our answer is actually going to be an approximate answer. Okay, so to find the volume of a cone, there's only 2 things you need to know. The radius, I know the radius, it's 9, so I'm going to go 3.14 times the radius, which is 9 squared, multiplied by the height, and then the height, remember, always goes from the top or the point of the cone down to the middle of the base, and the base of a cone is always a circle. So my height is going to be 17. So 3.14 multiplied by 9 to the second power, I'm going to multiply that by 17, and then I'm going to divide that by 3. There's my formula. Okay, so once I get that, I could just type it into my calculator to find the volume. So I'm going to go 3.14. That's my approximation for pi. And I probably want to do it this way. I'll do parentheses. Okay, then I'm going to multiply that by 9 to the second power. And if I use parentheses, I could type it all in just like I wrote it. Then I'm going to multiply that by 17. Okay, I'm going to see what that all equals. So I get this 4323.78, but then I have to divide by 3. Okay, so I get 1,000. So my volume in number 7 is 1,441 point, and then if you get a decimal, I want you to round your decimal to the 10th spot. The 10th spot is the first number value to the immediately right of the decimal, so that'd be the 2. The 6 would make that 0.3. Okay, so 1,441.3, put the yards and then to the third power. Okay, so there's my volume for number 7. Moving on to number 8. Okay, so once again, the formula for volume is you take the number pi, you multiply it by the radius squared, you multiply that by the height of the cone, and then you're going to divide it all by 3. Okay, so once again, the only 2 things you need to know to find volume of a cone is the radius. Do I know the radius of the cone? Well, yes, I do. That right there is your radius of your cone. Okay, so it's half of 12. So my radius is going to be 6. Remember, 12 is the diameter. That makes the radius 6. So I'm going to take 3.14, which is my approximation for pi. I'm going to multiply it by 6 squared. I'm going to multiply that by the height of the cone. So the height of the cone always goes from the point of the cone straight down to the middle of the base, which is the circle, has to make a 90 degrees. So my height is clearly marked as 8. And then I'm going to divide all of that by 3. All right, so working this out, once I get to this point, all I have to do is type this into my calculator. Okay, so let me get it so you can see it. There we go. All right, clear out my calculator. So I'm going to go parentheses, 3.14. I'm going to multiply that by 6 squared, and I could just type in 36. Why? Because 6 squared is 36. Then I'm going to multiply that by 8. I'm going to see what that all equals, and then I divide by 3. So I get 301 point, don't put 0.44, just go 301.4. I just want you to round the answer to the nearest tenth. Okay, so there's my numerical answer for the volume of number 7. Put the measurements, which is inches, and volume is always in cubic units, so cubic inches. 301.4 cubic inches is the volume for number 8. Okay, number 9. Once again, we're finding the volume of this. So the volume formula for a cone is the number pi multiplied by the radius squared multiplied by the height. You may notice that. You may be thinking to yourself, yo, Mr. Trutna, Why do you always write the formula down? Well, I write the formula down so that I just have a better chance of remembering it. You should memorize this formula, but you should be screaming at the video right now, that's not the formula yet, Mr. Trutna, because you still got to divide by 3. There we go. So, do I know what pi is? The answer is no, but do I approximate pi? The answer is yes, as 3.14. Do I know the radius of this cone? Yes, I do. The radius would be from the center of the base, the circle, to one point there. So that is going to be 12. Okay, it's half of 24. So I'm going to go 3.14 times 12 squared. Now, do I know the height? The answer is no. I don't know the height, because remember, the height goes from the point of the cone, the top point of the cone, straight down to the middle of the base, which is a circle. It makes a 90 degrees. So I don't know that right there. Well, I do know that that part is 12, and I do know that that part is 13. And by the way, what's 13 called? What's that called when it's on the side of the cone? Remember, that's called the slant height. So think back. If you know the slant height of a shape, and we did this in a pyramid earlier, what are you probably going to have to do to find the height of the shape that you're doing, the solid that you're working with? Well, you're going to have to use Pythagorean Theorem. So I'm going to have to use Pythagorean Theorem with the h and the 12 as the legs. So I'll work it out over here. So I'm going to go h squared, one of the legs, squared, plus the other leg squared, which is 12 squared, and that's going to be equal to the hypotenuse of this right triangle that I created right here, which is 13 squared. Okay, so remember, typically if you're given a slant height of a solid shape like a cone or a pyramid, and you have to find the height, there's a darn good chance you're going to have to use Pythagorean Theorem. Just keep that in your back pocket to remember. So I'm going to simplify this. h squared cannot simplify. 12 squared simplifies to 144. 13 squared simplifies to 169. I subtract 144 from both sides of the equation because I want to isolate the h. So I get h squared is equal to 25. 169 minus 144 is 25, excuse me. Then I take the square root of 25, which is 5. So that means my height of my cone, I just had to use Pythagorean Theorem, I found it to be 5, and then I'm going to divide it all by 3. So now when I get to this point, I just type it into my calculator. All right, so I'm going to go 3.14, that's my approximation for pi, times 12 to the second power. I could have put 144, all right, times 5. I see what that equals. Don't worry about writing it down yet because we still got to divide it by 3. There's my volume, 753.6. So my volume is 756 cubic kilometers, so km cubed, cubic kilometers. There's my volume for number 9. Okay, so now we have some applications for numbers 10, 11, and 11. Okay, so number 10, it says a cone has a volume of 1,309 cubic centimeters. If the height of the cone is 8 centimeters, find its radius. Okay, so watch how I'm going to do this problem. So I know, first thing I'm going to do is I'm going to write down the formula for volume. I always start by writing down the formula. Volume is equal to pi, this is for a cone, times the radius squared times the height of the cone divided by 3. Okay, so then what I'm going to do is I'm going to fill in all the information that I know from this problem. Do I know the volume? Yeah, it's 1,309. So I'm going to substitute in the place of V, 1,309 is equal to, what can I substitute for pi? Well, I can substitute 3.14 for pi. What can I substitute for the radius? Was I told the radius? No. So I can't substitute anything for the radius, so the radius is going to stay r. What can I substitute for h? Well, the height of the cone is 8 centimeters, so h, I can substitute 8. And then I divide by 3. Okay, so really what I just did was, for this problem, I'm going to have to work backwards, and I'm going to have to I created this equation. All right, in order to solve it out. And I'm going to have to solve it out for r. All right, so what do I do now? Well, there's a couple things that I could do. First thing is, I'm just going to systematically, one step at a time, get rid of the 3, the 8, and then the 3.4, one step at a time. How do I get rid of the 3? Well, I'm dividing by 3, so that means I'm going to multiply both sides of the equation by 3. That would cancel out those 3's. 3 times 1,309, watch this, 3 times 1,309 is 3,927. So when I do that, my equation becomes 3,927 is equal to 3.14 times r squared times 8. Okay? So now I'm going to get rid of something else. What do you guys want to get rid of next? Well, I'm going to get rid of the 8. So how do I get rid of the 8? Well, I'm going to divide both sides of the equation by 8. That would cancel out those 8's. So 3,927 divided by 8 is 490.875. Now I'm going to write the whole decimal down, and the reason why I'm going to write the whole decimal down because I don't want to round my answer until I have a final answer. So I'm going to get that. And then I have 490.875 is equal to 3.14, there's my pi, times r squared. So now I want to get rid of the 3.14. So I'm going to divide both sides of the equation by 3.14. And I'm going to get probably a pretty ugly looking decimal. This decimal is going to get a lot uglier when I divide by 3.14, and it does. I'm not going to write that down, okay? But those would cancel out, and what you need to know is now my new equation becomes 156.3296178. You know what? For this problem, I'll write it down. What the heck? I got nothing else to do today except for do math. 3296178. That's going to be equal to r squared. So if r squared is equal to that, what do I do to that number to find r? Well, I take the square root. And on this calculator, I could just tell it to take the square root of the answer. All right, so there's my answer. 12.5 is going to be my answer. So my radius in this problem is 12.5. So that's how you would go about doing number 10. Okay, number 11. Caitlin must build a sandcastle in the form of a square pyramid for a project as shown to the left. Okay, so here's her project shown to her left. So this problem right here, this pyramid goes with number 11. She bought 3 bags of sand. Each contains 1,200 cubic inches of sand. Will she have enough sand? Okay, so what this problem is saying is, remember, volume is how much stuff you can pour inside a shape. So what we have to do in this problem is we have to find the volume of this pyramid. Okay, so what's the formula for volume of a pyramid? Well, it's area of the base, denoted by capital B, times the height of the pyramid, denoted by lowercase h, divided by 3. Okay, so this right here is the base of my pyramid. And if you notice, it's a square. So how do you find the area of a square? Well, you go the side times the side, or the length times the width. So to find the area of my base, I'm going to go 25 times 25. Then I'm going to multiply that by the height of the pyramid. So the height of my pyramid is this line right here, which is clearly denoted as 18 inches. So the height of my pyramid is 18. Okay, so I'm going to find the volume of this pyramid by going 25 times 25, timesing it by 18, multiplying it by 18, and then dividing by 3. Okay, so 25 times 25 times 18 gives me 11,250. I divide that by 3, so I get 3,750. So my volume is 3,750 cubic inches. Okay, now that's not my answer, so I'm going to circle it. I'm not going to put a box around it. That's not my answer. Okay, the question is not what's the volume. The question is, will she have enough sand to build the castle? Well, how much sand does she have? She has 3 bags times each bag holds or contains 1,200 cubic inches of sand. If I multiply that out, she has 3,600, 3 times 1,200 cubic inches of sand. Okay, so this is how much sand she has. That's the volume of the pyramid. So does she have enough to build the castle? The answer is no. Okay, so it's no. She's short. She's 150 cubic inches short in order to build a castle. She needs 3,750 cubic inches. She only has 3,600. Okay, so sorry, Caitlin, you're not going to be able to build the sandcastle. Okay, all right, but that's okay, Caitlin. It's all right. Build something else instead of a sandcastle. All right, so number 11. The cylinder to the left contains 2 congruent hollow cones. If the cylinder's height is 20, so let's mark that. We know the cylinder's height is 20 inches, and its diameter is 14 inches. Find the volume of the cone. So the diameter of this is 14 inches. Find the volume of the solid, excuse me. Okay, so this is not drawn well. You can't see it because when I copied it, it made so dark. But what's going on in here is inside this cylinder, we have 2 congruent cones, okay? So inside the cylinder, and I don't know if this is going to translate. We have, yeah, you can kind of see it. You have this cone, and then you have another cone inside the cylinder. Okay, so you've got these 2 cones. So it's kind of like an hourglass, and you can kind of see it when I drew it. It's kind of like there's an hourglass inside the cylinder. So what we have to do is we have to find the volume of the cylinder. Okay, so how do you find volume of a cylinder? Well, remember, you take the area, or you take pi, you multiply it by the radius squared, then you multiply it by the height of the cylinder, okay? But then, after we find the volume of the cylinder, which is the whole thing, we have to subtract out 2 of the cones, 2 volumes of the cones. Why 2? Because there's 2. So the volume for a cone, remember, is pi times radius squared times the height of the cone, and then divided by 3. But we're going to have 2 of those, so that's why I put a 2 there, because we're going to have to multiply by 2. Okay, so let's fill in what we know. Okay, so we know pi, so that's 3.14. So remember this first formula here, this is for my cylinder. Do we know the radius of the cylinder? Yes, we do. The radius of the cylinder is there to there, which is 7. So the radius is 7. The diameter is 14. Okay, so we're going to go 3.14 times 7 squared. And then do we know the height of the cylinder? Yes, we do. It's 20. Okay, so let's work that out first. And let's see what that equals to, and let's write that down. Okay, so 3.14, whoops, want to do it in parentheses, 3.14 times 7 squared. I'm just going to put 49. Is that okay with you, Ismet? Okay, good. Ismet says yeah, because 7 squared is 49. And then I'm going to multiply that by 20. Okay, so my cylinder is 3,077.2. Okay, so that's my cylinder, 3,077.2. Now let's go ahead and I'll work this out in red. Let's find the volume of both cones. So 2 times pi, we're going to use 3.14, so that means we're getting an approximate answer. Do I know the radius of the cones? Yeah, it's the same, so the radius is 7. 7 squared. Now here's where we have to think a little bit. What's the height of a cone? Okay, just one of them. So right there, you can barely see it. It's not a good copy. So that right there, how long is that line? Well, it's half of 20. So the height is 10, and then I'm going to divide by 3. Okay, so now I'm going to work out this red part here. All right, so I'm going to go 2 times 3.14 times 7 squared, which Ismet said was 49, and I agreed with him, times the height is 10. I'm going to see what that equals. Okay, and notice that's the same number as I got for this, but then I have to divide by 3. Okay, so that means I get 1,025.7. Okay, don't put 0.73, that 3, don't put 0.8, that 3 would not round that up, so I get 1025.7. So I'm going to go minus 1025.7. So my volume of the solid, which is like the cylinder with that hourglass taken out of it, is going to be 3077.2, so 3077.2. Subtract out of it 1025.7. There we go, 2051.5. Okay, 2051.5 cubic inches. So there's the second number 11.